Brian is a very special guy with many attributes that allow for his perfection. Let's take a closer look. First of all, Brian comes in all different shapes and sizes, however this doesn't have an effect on how he functions. One of the biggest attributes that Brian has is his frontal lobe. If we go right in here. There we go. We can see Brian's frontal lobe. This depicts his ability to use reasoning and problem solving like in this video clip. Here, as we can see, Brian used problem solving to build in front of him, saving his life. This kind of thinking derives from Brian's frontal lobe, one of his many attributes. Next, let's look at Brian's temporal lobe, an attribute of his that is associated with a very important feature, language recognition. In the following clip we will see how Brian uses language to communicate and win a game.
Are you? I have a med kit. I have a med kit.
I have a med kit as well. Yeah.
I have no ammo for anything.
Oh, I see him. I see him.
Where is he? Where is he? Call him out. I got a rocket launcher.
West 275.
Right
West
behind the
275.
trees,
He has a
behind the
legendary
trees.
scar for sure. He has legendary scar for sure.
Yeah, he's out in the open. He's out in the open. Come on, bink that.
Okay, wait. Let's
I
get
have
back.
no ammo. I have no
Get back.
ammo.
Then
It's
get me up, I'll
literally
give you
just him.
shit.
The other guy is down. The other guy is down. I'm trying to move in. He's building up. He's building up. He's building up. Let's go!
Yes.
Let's
Good job,
go.
guys.
I'm never playing Fortnite ever again. Wait, I gotta snap.
As we can see, the temporal lobe offers Brian a very important attribute. In that clip, Brian used communication with teammates to be able to find enemies and take the dub. Being able to communicate with other Brians also allows for an advanced species as well as complex thought and discussion. Next we will see Brian's ability to use his occipital lobe. This part of Brian allows for his to process things visually, another one of Brian's vital attributes. In the following clip we will see how Brian uses this lobe and effectively spots an enemy's shadow on the ground. Because of Brian's ability to process things visually, thanks to the occipital lobe, he was able to spot the enemy. Without the occipital lobe, Brian would have been a goner for sure. Next, let's look at Brian's parietal lobe, the part of his brain that is associated with his sense of touch and taste. Brian is able to process this information within seconds, hence why when you touch something hot you immediately flinch and or jump back. Or why you love to eat certain things and hate to eat other food. In the clips that have been playing we can see Brian enjoying a nice delicious drink, which in turn gives him armor. Now that we've discussed how Brian works and his respective attributes, or lobes, let's take a look at Brian Jr. Brian Jr. is a teenager that is on his way to obtaining all of these special abilities, however he's not quite there. One of the main things that Brian Jr. lacks is the full development of his frontal lobe. Because of this Brian Jr. can be, how do I put this? Stupid at sometimes. He tends to think that he can do anything without repercussions and will make irrational decisions from time to time. Brian Jr. won't become a full Brian until he's roughly 25. Let's look at some videos of how Brian Jr. is doing. It isn't just the fact that Brian Jr. has a late developing frontal lobe, but there's other factors that make him different than Brian. First of all, Brian Jr. has more hormones that release into him, increasing risky behavior as well as attracting him to other Brians or Brianettes. Also, melatonin gets naturally released into him much later than that of a fully developed Brian, leaving Brian Jr. to get much less sleep, hence why the school is changing its starting times next year. Brian Jr. also gets frequent mood swings due to his emotional regions behind the prefrontal cortex being much better connected, meaning all of his decisions are immediately associated with emotional impulses. The reason we know the things we do about Brian is because we have new tools of discovery that are used to be psychologists to analyze him. These new tools are called the thicc, CAT, PET, MEG, and fMRI or just MRI. Each of these tools observe brain activity and can be recorded down and compared to others to help find patterns within certain activities. For example, the thicc scan observes human brain activity in a non-invasive way, gaining electrical impulses and changes of just a split second. Whereas with the PET scan, patients are injected with radioactive glucose which is then detected by the outside of the scalp, observing brain blood flow and metabolism. During the CAT scan, two-dimensional images are used to create three-dimensional images of internal organs in the brain. Next, the MEG scan measures the faint magnetic fields that emanate from the head as a result of brain activity. Finally, the fMRI realigns the body hydrogen atoms using a magnetic field. Overall, all of these discoveries have played a very important role in finding out more about our friend Brian and his miraculous ways. The last thing we will talk about today is the basic structure and function of a neuron. The neuron is the part inside of Brian that generates impulses and helps it function. The soma acts as the control center of the neuron. The dendrites receive information from other neurons and transport it to the soma. The axon organizes the information. The nucleus carries the information down the tube-like structure of the neuron in an electrochemical impulse form. The myelin sheath is the fatty layer that covers and protects the neuron and speeds up its process. Finally, the terminal branches have knob-like tips that come close to other neurons' dendrites. The neuron itself has multiple functions, like action potential. Action potential happens when the neuron is fired and the impulse travels down the axon to the terminal branches. The refractory period in the neuron is the time when there is no potential for action as it is in a resting state. Finally, the resting potential in a neuron happens when the neuron is charged and is waiting for action potential to be generated. After action potential is expended and it reaches an axon terminal, it releases neurotransmitter molecules from sacs called vessels. These molecules cross the synaptic gap and bind to receptor sites on the receiving neuron. Now let's take a look even further into Brian. The first structure we'll see when entering is the pituitary gland, which is the master gland of the endocrine system. Next we'll find the medulla. The medulla controls Brian's breathing and heartbeat. After this we'll find the pons. The pons not only help with breathing and heart rate, but also connect the medulla to the two sides of the cerebellum to help coordinate and integrate movement on each side of the body. Next up is the cerebellum. The cerebellum assists in balance and coordination of voluntary movement. Further into Brian we'll see the midbrain. The midbrain integrates specific types of information from the eyes and ears where it will then send it to other parts of Brian. Next we see the thalamus. The thalamus routes incoming messages from all the senses, except smell, to the appropriate brain areas for processing. The hippocampus. The hippocampus is the part of Brian that saves new memories. The amygdala regulates emotions such as fear and rage inside of Brian. Finally, the hypothalamus regulates hunger, thirst, body temperatures, and the pleasure centers of Brian. The first case study we looked into was the miraculous story of Phineas Gage. Phineas one day found himself packing down gunpowder into a hole to help build train tracks when out of nowhere a pipe flew out of the ground and went directly through his head. The pipe went through his corpus callosum. Many thought he would have immediately died, however that was not the case. Although taking a very severe injury to the ventromedial region of his frontal lobe, Phineas lived on, albeit with extreme personality change. This is important to psychology because without this particularly odd incident that happened in 1848, psychologists would not have observed brain injury of this severity with a living survivor that took on such repercussions like his extreme personality change. The second case study we looked into was Dr. Broca's patient who had lost his ability to speak due to a stroke. After the patient had died, Dr. Broca studied his brain to realize that he had brain damage on his left hemisphere. Later on, Dr. Broca discovered a patient with comparable damage to his brain, however he could speak. Dr. Broca also noticed that the damage he took was on the patient's right hemisphere and not the left. This study is significant to psychology because of the fact that psychologists could draw the conclusion that speech is held within the left hemisphere of the brain, whereas the right hemisphere has no effect on speech. Last but not least, we will be discussing the topic of split brain research. When your brain is split in two, by cutting the corpus callosum, your body loses the ability to communicate between both hemispheres of your brain, resulting in two different minds. In an experiment conducted on split brain patients, words were flashed on the screen while the patient's left eye was covered. When asked what he saw, he answered the word correctly. They then covered the patient's right eye and flashed the same word on the screen. This time the patient had no idea what the word on the screen was. This shows that the hemispheres were not able to communicate because one side was seeing something but it could be communicated to the other side without the corpus callosum. Another cool thing that we found, that furthers the ideal of two separate minds, is that those who are split-brained are able to play games like checkers and tic-tac-toe against each other. This is because both sides of the brain cannot communicate, virtually making them two different people.
Ocean man, take me by the hand.